Welcome back to the channel, guys. Tonight, as you can see, I am set up to check for a battery draw. Now, if you didn't get a chance to watch my last one, a couple days ago, I just got rid of a BMW. That was another tough battery draw, but we got that one nailed down correctly. This one, it's a 2013 Dodge Ram 1500. And the customer called me because funny story was that they basically showed up at my door straight from picking it up from the local Dodge Chrysler dealer here in town. He explained to me, he actually showed me the invoice RO, and their story was that mainly basically the complaint is that the vehicle dies after a couple days of sitting. They checked it out, said that the battery was bad, replaced it, did a draw test for an hour, nothing was found, considered the vehicle to be good, just a faulty battery. Customer went, paid for it, and when he went to go get in it to drive away, the vehicle was dead. They needed to jump start it after it was there for dying after a few days, and they called it a bad battery, yet the customer paid, and paid a lot, mind you, and needed to be jumped to get it out of there. So he left there and drove straight here and basically left it and asked me to find out what's going on and see if I could get to the bottom of the problem. As always, I set up my Vantage Pro, the amp meter, in series with the ground side of the battery, and then I'll watch to see if there is a present current draw. As you can see, we've got activity, and we're somewhere in the range of a pretty hefty draw. It's a 3 amp draw, so that's again pretty high up there. So as far as the dealer, I don't know. Not sure why they can catch this and, chase this down. But this is what we are dealt with. It's here on our lap. This is what we currently have. Now we have to chase this down. A quick walkthrough. Big obvious thing that I've noticed, and you clearly see, is the cluster. It is lit up. It's powered up. Not all the way because the center screen's not displaying anything, but it's obviously not asleep. Again, I can show you some images that I use with the thermal imager, trying to see if it becomes a useful tool or not. This is the one I ended up picking up. I tried to use it on my last one. It really didn't give me a guiding sense of direction or help. It just let me see what we already had confirmed. Once we found out the module and whatnot, obviously we could see it was heated up. This one, we clearly are going to see a cluster that's going to be on and hot on the thermal imager. So I'll show you some of the components. I believe it's 3 components that are showing up as being hot. So, and then from there, I'm going to probably go my regular route and start looking at fuses and draws on fuses. Okay, so we are back at this vehicle, the Dodge Ram truck that came in for a battery draw. The footage that you will see, or that I showed, was from the day that it was dropped off or later in that evening. Obviously, it was a spontaneous drop-off. They were kind of in a, I don't want to say urgent or rush, but they were trying to find out some sort of answer kind of quick, because this is from another shop. The shop sent it to the dealer, and then from the dealer to me. And the time frame from when it sat at the shop or they looked at it was quite a bit of a while. Then it went to the dealer, again, quite a bit of a while. And so now it's here at my lap, and it's here with the same result as from what the actual true owner and customer brought it to the first shop. So, of course, the pressure gets put on me to, let's call it, rush the time frame. So after the first day that I actually got to verify that there was about a 3 amp draw, I disconnected my equipment, basically the amp meter, because seeing that we had a 3 amp draw in my past experience tells me that, okay, I can hook up, set up, power up, or let the vehicle go to sleep, and we will see that 3 amp draw and then start chasing the circuits. This vehicle did not show that 3 amp draw the next day or the day after. I kept hooking up, disconnecting, hitting the locks, unlocking, starting, letting it idle, shut it off, lock it again, hooking up and monitoring. It would not go to that 3 amp draw. It would either go to a 20 milliamp or a 10 milliamp, which is perfect. That is a perfect range where you want your vehicle to sit. It won't ever kill the battery. Today, it's now the third day, of course, after a phone call from the shop, which was questioning as to what was going on or wanted an update. I told them I can't not test for a draw if it is not drawing. So the only thing that changed from when it came here to the testing that I did, which I let it sit here, was it was driven here, and then I checked for a draw almost right away or not too long after that, and the draw was present. After that, it just sat here and I checked, no draw present. So earlier today, I drove it around, ran a couple errands, let it idle for a while, came back to the shop, let it sit, and I would almost say I hooked it up as soon as I got back with the amp meter, still no draw, was in the 20 milliamp range. It has been about 4 hours later, and it finally showed its ugly face, and I currently have a 3 amp draw. Now, just to show you the effort that I've been putting into it because of everyone being upset and calling and wanting an update, so on and so forth, blah, blah, blah. Let me show you this. So, it is now past midnight on a Saturday, technically Saturday, but Friday night. So Friday, yes, Friday, end of day, is when I got in it, drove it around, so on and so forth, trying to get this to start to draw. So, I have now been here since past 5 o'clock. After that, I drove it, parked it, set it up, let it sit for 4 hours to finally, and I'll show you, catch a 3 amp draw. What else do we have with that? A cluster that is lit up, just like the first night when I showed you guys. So, again, the effort, the time that I am putting in to try to chase a circuit through the fuse box while we have a currently present current draw. So, enough of my crying about the time that I'm spending here. Off camera, as soon as I saw that 3 amp draw, I started to chase some circuits on the fuse box, and I've kind of sort of mapped out here and labeled them, and then wrote down the fuses and where they go. So I've got a 10 amp mini fuse that had a 1.0 millivolt, that's fuse 94. Then another 10 amp that had 0.2, that's fuse 80. Another 10 amp that had 0.2, that's fuse 82. 15 amp that had 0.2, fuse 84. Then let's see, a 10 amp that had 0.4, that's fuse 67. A 10 amp that had 6.2, that's fuse 49. Then another 10 amp that had 0.8 and a 5 amp that had 0.2. So I've got all those labeled, fuse 94, shift by wire, and also a transfer case switch as far as the diagrams. Fuse 80, the compass module. Fuse 82, steering control module. Fuse 84, upper bank switch and AC heater module. Fuse 67, media port, external disk module also. Fuse 49, cluster. That is this guy here, fuse 49, 6.2, the biggest draw, cluster. Fuse 51, keyless ignition node, basically ignition switch, and then the radio frequency hub. And then the smallest 5 amp, fuse 52.2 draw, the intelligent battery sensor. So with that, we can clearly go after the cluster because it has the highest draw that we measured, and clearly it is lit up and on. But just like I showed you in that last video with the BMW, what you see as far as the draw doesn't necessarily mean it is the cause of what is killing the car. Something else can keep what you think is drawing the most awake, and you need to find out what is keeping that awake. Now, I did not find the fuse currently for the radio, but with the thermal, both the cluster and the radio are on and hot and seem to be drawing. And this time around also off camera, I did the same picture deal, and the radio is also still drawing. I think the radio has a separate fuse that's not incorporated in here. Apparently, I think it's off of the positive cable. So that's another thing to consider. But what we have to do is go through this list, and these are not all the fuses. I did not do the J case fuses that have covers. We could have some fuses there that are drawing or have activity on as far as millivolts on the circuits, and I just have not measured those yet. But what I want to do is basically play the lottery. Pick one of these. I'm gonna pull the fuse, and I want to see if the draw comes down. So, for example, if I were to pull the cluster fuse, which has the highest draw, and we still have an elevated, unacceptable level on the amp meter, that means that the cluster is not the cause of the draw, it's just an added additional factor to the draw of something else that's still awake. But what I think I want to do is pull a different fuse and see if the amperage reading comes down, including the reading for the cluster, and that can tell me if that is the true cause of keeping everything else awake. Now, the shop brought it to me with, they had some suspicion, they saw some bulletin or something about the radio frequency hub, and he kept asking if that's what's at fault. And I said, I cannot determine that unless I can test it if it is one of the circuits that is drawing while we have a draw currently present. So with that said, we are having a draw on the circuit that module is on fuse 51. So just to appease and please and to get a starting point, I think I'm going to pull that fuse that has and incorporates the radio frequency hub and also the basically ignition switch, and see what the rest of the levels go to on the other fuses, or basically look at the amp meter and see if we drop down to an acceptable level from the point that we are starting with a 3 amp draw. Now, if that does bring it down, we still have to decipher between the two of these guys, because that is also a common failure point, the ignition switch we'll call it, and maybe from what they saw or read about the radio frequency hub, could also be a common point. So I'm going to start with pulling fuse 51. We'll check and see what the amp meter reading goes to while still having the fuse powering up the cluster. We want to see everything come down to an acceptable level while we pull that fuse. Okay, so I am going to go for fuse 51 there, which is above the 5 amp fuse, which there's the 5 amp. Here is fuse 51, and I'll keep you here. Now, I haven't pulled it yet, but you have to keep in mind we might still have a need to do a sleep period point, where after we pull it, we might have to let it sit and monitor for the modules to go to sleep after a change in the basically amp activity. So 3, 2, 1, pulled it. We definitely have a change in the amp meter. For now, we need to sit and wait to see if it will go to sleep after pulling the fuse. As we see, I'm going to put that here. And I'm actually going to change the scale to try to record the amperage activity better. If that's 2 amps, let's go to 5 amps. Alright, so I'll let that sit for a while and see where that goes to. And just to get a shot, let's take a quick look. Cluster is still awake, but again, we have just recently pulled that fuse. Let's see if that being off the circuit lets the cluster go to sleep. So again, we'll let it sit for a while and see what the amperage meter goes to and see if that shuts off and goes to sleep. Okay guys, so I will put up a picture of the amp meter, the Vantage Pro, after I removed the fuse for the cluster. It did drop down some, but not a great amount, and we still had the same repetitive activity on the lower scale after we unplugged the cluster, meaning there was uprises that would be up down in the higher amperage scale, and then when we unplugged the cluster, we dropped down the amperage scale, but we still had up down activity as far as amperage goes. So what I've got now, so I'm clearly showing that the cluster is off, it's not lit up. I decided to move over to the the radio itself. I've unbolted it, it's not unplugged, and to the touch here in the back, it is warm for sure. So the radio frequency hub fuse with the ignition same fuse did not make a difference. We still had high amperage. We then removed the fuse for the cluster. It dropped down some, but not to an acceptable level, and we still had activity, as what I keep calling the whole up down. being that our radio screen looks like it's seen better days, let's go ahead and unplug this guy and see if we drop down. So I'm bringing you guys along. Let's figure out how to do this with one hand. There we go. So let's unplug. Let's go check the meter. We've dropped down yet another amount of level. But we are still getting that up, down activity rise, and we are still at over 1 amp. Okay, guys, so it is now the next morning. Stayed here late last night trying to chase the draw, and it was kind of just getting useless at that point because it was just late and I just was not in the greatest mood or state or whatever you want to call it. So I was kind of just at that point just start pulling fuses, so on and so forth. I left it hooked up overnight hoping that it would stay drawing, and this is where we are at with it. So we do still have a constant high draw. Let's see. And you can tell we still have that repetitive pattern as well. Again, leading me to believe that there's a module involved. Here are, again, at that point last night, I just ended up pulling all those fuses that I had recorded some values in, and it made no difference as far as bringing it down to acceptable level. That's where we're left with. So we can safely say with these out overnight, none of these attribute and contribute to the draw that the vehicle has. Obviously, we have the cluster fuse removed, so that's not coming into play. The radio is unplugged with the main connector, so that's not the issue. So I guess I will just continue on chasing this, hopefully just well rested and can think better. Now, I just quickly want to touch base on a subject that some of you might question. Some of you might ask, why am I not connected and hooked up to any of the buses? And honestly, truthfully, for me, I've never used that method in the past to chase a draw. Now, I'm not saying it's the wrong way or incorrect way. I've just never got accustomed to using that method. And so it's not really my first go-to. This is normally what I'll do. And so a couple things that with how I do it is with the amp meter, but with the graphing portion also. That gives me an idea of the type of draw. I've said this before in other ones. So if on that pattern is just flatline up at, say, 1 amp, we can attribute that to, let's call it like a glove box light bulb staying solidly lit on, and it's just a constant, steady draw. And we can see that when we graph out the amperage. Now, if I see a pattern like that, a bulb is not going to do that. So with a pattern like that, that I know is attributed to a module. There is a module that is causing the draw. Secondly, is the amount of draw is a second clue. If it's, say, a small amount, like basically I'll try to put up this BMW that I just got rid of. It was drawing from a module, but not a module activity. It just was staying awake and was due to an input to the module, but it was a singular module and it wasn't talking on the bus, meaning the module was awake and drawing through its processor, but it wasn't awake and talking on the bus. And so the level of amperage draw was, I'll call it minor. It was about 140 milliamps. Now, if you see something that's higher, then you can attribute to multiple modules being awake. So if on that last one, the module that was faulty was awake to the point where it was talking on the bus, I would have had a higher level besides the 140 milliamps. I would have had 300, 400, 500, 6, 7, on the draw, because then that tells me that's more than one module and it's awake, and if more than one's awake, then they're talking on the bus. So what I'm trying to explain is that I can basically guarantee that there's activity on the bus, and I don't at this point feel I need to tap into the bus because I am watching activity through the amp meter of a module creating this repetitive pattern draw. I think at that point, watching the bus would just be redundant to what I'm watching here. Once you get rid of the bus activity, you get rid of the draw. So right now, I'm using this method that I've always used. I don't know if I need to go to the bus right now. I'm not saying it's incorrect. I'm saying I'm just going by what I see here, which is a pattern draw created by a module, and then the level up there in the 700 to 1 amp tells me it's more than one module being awake. And so with that, I hope I made myself kind of clear as to why I haven't gone to the scope and the bus and why I'm using this. The other thing, I just, again, in that last video, explained that I got the thermal imager, and of course I've showed it earlier in my starting procedure here. I'm going to just hook that up again out of curiosity because we've got so many circuits removed, let's call it. We know we're not going to see the cluster lit up, the radio lit up, so on and so forth. So with these guys removed off the circuit, I'm curious to see if the thermal imager will show me anything else at this point where it's sat overnight, drawing with all those circuits removed, and see if I pick up anything at all, and if the thermal imager can help guide me at this point. Okay, so I will do my best to capture this via a second phone. Obviously, we see the Vantage Pro lit up, and again, earlier, the fuse box, there was nothing there. I did this off camera, and if you see that little bit down at the bottom, something is lit up. I didn't catch that earlier, or it wasn't hot earlier, let's call it. So there is something for sure lit up down there. So if I come over to the other side, that's the charger for the Vantage Pro. And look at that. There we go. We got a clear picture of something being hot and lit off. Now, what can that be? That is the ABS control unit and hydraulic pump. That is drawing, or it is creating some heat, which would tell us that it's drawing some amperage. Now, that's a good sign. Obviously, we still have the draw. Now, one other thing I did fine. Obviously, we are not going to have anything there, but down here, hopefully I can capture this. You see that there is another module. Now I don't know exactly which one that one is, but it's a big module. It's white in a white case and has some connectors on it. But it is also drawing. So that's two modules that we see currently drawing some amperage due to its heat. So right now, the thermal is helping me give me some guidance since I've pulled all those circuits currently that didn't help find the true cause. So let me investigate on those two modules. Okay guys, so after looking at the power distribution, and I think I mentioned this, the fuses powering up both ABS and that module inside, it's actually the BCM, which I kind of had a feeling it was going to be BCM, but after verifying, it looks like they are all big, heavy 40 amp fuses powering up both modules and multiple fuses. And so I'm going to assume it's some of these JK fuses that we didn't test yesterday. Being that right now we currently have two that are causing that, two modules, I think I'm going to continue on my quick and dirty. Instead of messing with the fuses and stuff right now, I'm just simply going to unplug and remove that guy from the system completely instead of removing the fuses for it. And then we'll watch that. If the BCM is good, we won't have that, and if it is the ABS causing that, we will lose that. So I don't want to remove the BCM off of the system right now because I'm assuming it's going to be a big player. And so I'm hoping it's the ABS causing this draw, but the only way is to let's unplug it, see what it does. Okay, so I've got you pointed at the Vantage Pro and trying to see what the best way to unplug that is. I don't want to disturb too much and mess the amp meter leads. I might be able to get the connector through the bottom, so hold on. Alright, we are unplugged. And we have dropped down to a significant amount. We've lost that pattern. I'm gonna let it sit, and up to about the 45-minute deal. There we go. Look, we just dropped as I'm talking down to 20. Wow. Oh man. Okay, so hopefully that is going to be our issue, which right now it definitely looks like it. I mean, it's again, as I always say, that's undeniable live data that we are watching, and that repetitive pattern, I think the more important thing, has been lost, or it's gone. And it looks like BCM is not going to be the issue, but would make sense that it would possibly stay awake if the ABS is awake and talking through the bus, because I assume that the BCM is going to be on the bus or have a leg on the bus that the ABS is on. So just thinking out loud, trying to, clarify for everyone that I don't know if watching the bus would help on this one. Again, just kind of going through why watching the raw amperage reading at this point. So again, we'll let it sit for a while and hope that it stays that way. Now, the last thing to do would be to put all those guys back in circuit and hope that that stays away, which I am kind of very confident, because knowing that all those guys were off the circuit. They literally have nothing to do with keeping the bus awake, with keeping a module awake, and none of those were causing the draw. So now I will say all those other guys, like obviously the cluster and the radio, were awake and adding and contributing to the draw because they naturally were awake. So they will have to draw if they're awake. But removing those, all those guys that had a amount of draw in millivolts that we found, all removed, all those guys were being kept awake by what's going on the bus. And so each one you remove, you drop the amount, but it's still at a high level that was not acceptable. So I bet that I'll probably be okay, being that those guys were not the true contributing cause of the bus and the draw being current. Okay, and as I said, so it is about 11:20. I'm going to turn this light off. We are still at the 20 milliamp. I'm going to run, grab some food, come back, hopefully around 45 minutes or so, and we'll check on the level. Alright guys, so it is now, it's about 1:30, so I got tied up a little bit, so it's a little bit of an extended break, but it gives us a good chance to check and see. So let's see, that whole time we have stayed at that level. And to prove it out, let's go ahead and stop this and get a shot of the whole time. And there we go. So that's where we dropped and stayed down at the 20 milliamps. So let's back out, let's start again. And so what I think I want to do to try to just verify, before I plug in the ABS, so that's what I want to do. Instead of putting these guys back in for right now, I'm going to plug the ABS back in and watch the scope there, the amp meter. But just before I do that, I am going to just just out of curiosity and everything, get the thermal imager, and obviously that should be cooled off, but I want to see what the BCM has done. All right, let's take a look at the ABS. Let's see. So it's definitely cooled off. It's not coming up on the screen down there, so you can see where we are. And let's take a look at the BCM. Now, I'll tell you, it's probably going to be cooled off because, again, if we go off of this amp meter reading, we know if there's no activity there, then no one is awake and talking. So, let's see. Alright, so this guy, clearly, as we pretty much expected, has cooled off as well. It's not stayed on drawing, and so we can most likely condemn the ABS. Alright, so I'll have you guys looking at the scope as I go down to plug the ABS back in. And just before that, now I don't know, now if you remember, this is basically sort of an intermittent draw. So I had a couple days where it would not act up. And so I don't know if plugging it back in is going to make it be right back at that same point where it was awake and drawing. We got to keep that into consideration. But I think up to this point, with what we have seen and the data and everything, when we unplugged it, to see the activity go away from that guy alone, pretty much can condemn that. But we're trying to just verify by plugging it back in. Again, I don't know what state it's going to be in when we plug it back in, so we might not have a draw. We're plugged back in, and we did go back up. Now, naturally, we always have the potential of waking the vehicle up when we pull fuses and put them back in, or we unplug modules and plug them back in. So we are going to have a waiting period, see how it acts up on the graph. All right, guys, so it's been about 25 minutes since we plugged in the ABS module, and I want you to take a look at this. Look at where we are at and how we are at. So we're back up to that same level as far as the number in the draw, but look at the pattern. We have that repetitive module activity pattern. 100% same thing when plugging the ABS back in. I'm not sure what else I can attempt to try to do, other than I think possibly at this point we're going to have to maybe call that guy faulty. I'm going to try to do, which I don't even know if I need to, but a final type of dagger test. The ABS communicates on what's called the CAN C. There you go. We have bus activity. There is our 3.6. So there is our pink and green. This guy here.